All right, good lunch, everyone. Who here has done a principal component analysis of anything before? Right, who here has done a vector decomposition, like a singular value decomposition? Who here has not done that? Okay.
Can you speak a little louder?
Who has not done a vector decomposition of any kind before?
Okay.
Nobody? Okay, good, because it's like monads. Once you understand it, you can't explain it. So then I can skip that part. Great, so let's just, you have at some point, I'm assuming, all of you, this is not true of course, but you have at some point done an evaluation of some kind, and you have a result matrix of numbers. And you have questions as columns, and then you have students or participants as rows. Or you could think of this as a sort of question dimensional point cloud, and you can do a vector analysis of this. So what we do when we're doing a vector decomposition, we're extracting the one that captures the largest amount of variance. Specifically, that's what we're looking for, and then we do orthogonal, capture successive amounts of variance. So the question is, well, when I did this the first time, I was like, fuck it, let's just try, see what happens. But of course, you could do it the more scientific way and be like, oh, let's formulate a hypothesis. How should it look like? What should we get? So let's do it the proper way, even though this is a completely post hoc and nobody actually works like this. But what should it look like? You have question A and question B. On this dimension, you have question A, and on that dimension, you have question B. What should that point cloud look like in terms of like achievement on question A and achievement on question B? What should it look like? Should it just be random? Should it be oval shaped? Should it be circular? Should it just be uniform? What should it be? What do we expect?
Define should.
As you would desire it.
Right.
Expectation and desire are two sides of the same coin. What do you think?
I bet it depends on the constructivistic viewpoint. If question B, to know B, you need to know A. Kind of probably this skews.
Yep, exactly. So in order, if there is some kind of interdependence in them, there you should be able to observe the interdependence. And so within your course, should there be interdependence between the questions that you propose in the course? There should be some amount, but it shouldn't be only, because if there's only, you're just measuring the same thing twice. Then you have just a completely straight line and everything falls in the straight line. So you should get some kind of skewed result. It's kind of skewed oval, but it's not perfect, right?
We should probably not go too deeply into this, but I think in some cases you want interdependence in terms of maybe question B digging deeper than question A. So
yes.
You want to measure how much do you know about this subject.
We are sort of presaging the conclusion. We want some amount of variance, but we don't want all of the variance, because then we're just measuring the same thing multiple times. So that's what we get. We get this kind of oval shape that extracts a large amount of information, but not all of the information. So this was what happened the first time I did this. I just plotted out the magnitude. This is the first most important vector. This is the one that captures the largest amount of variance. 18% variance captured in this one, I think, if I remember correctly. And we see some of these are positive and some of these are negative. So we're getting this. Most of these have some kind of intercorrelation with each other, but there are these weird outliers at the bottom there, which means that if we interpret this in some way, we can say that, okay, it looks like if achievement on this one correlates negatively with achievement on everything else.
It's unexpected.
That is unexpected. And this is why this tool is quite useful. Because we can find these unexpected things, and we can actually evaluate the questions based on this unexpected result, and we can go, here's something weird happened here, something that we don't want happened here. I'll take your question.
What are we kind of looking at? I know that this is the direction of most variance, but could
yes.
you give what does this mean for?
It means that the higher the value, the more it's pulling in that, the more important it is, the more variance it captures within that. So we're doing components here.
Yeah.
So the first component is this multidimensional vector across the question space. And this is the subcomponent of that in turn, which is how much is this question pulling that variance? How much of the variance is of the exam is captured by this one specifically? And we have this kind of negative variance for these weird ones, which means if it's exactly 0, it means this question doesn't matter. You didn't need to ask it because it has no effect. And if it's negative, it means asking this question has the opposite effect of what you intended. So doing well on this one correlates with doing slightly poorly overall, or inversely, doing slightly poorly overall on the exam correlates with doing slightly well on that one. And if it's very large, it means doing well on this one is a strong indicator for how well you did overall on the exam. So it's correlation-ish with the overall picture. It's not exactly that, but as a sort of introductory mental model way of thinking about it, I think this is instructive. So yeah, I know you were going to comment on that's not technically what it is, but it's, I know. Yeah. So, okay, so I'm just flipping the axes here. So I'm flipping the axes on the vertical because text is easier to read when it's horizontal. And then I am plotting them in sorted order. So I'm not doing them in the order the questions were asked, I'm doing them in sorted order. And this sort of spreads them from left to right. And there's no rationale beyond it looks nicer to do it this way. And I've also given them labels, color labels, based on what kind of topics there were within that exam, and those labels will become useful later, but they're not that useful right now. So you can think of these questions that are highly on the positive end. You can think of these as strong questions. You can think of these two questions at the bottom there. They were effectively quite bad questions. We'll get into exactly why later. And you might think of these, okay, these might have been weak questions. We might, if we're doing a recurring evaluation or we're doing the same kind of evaluation later, we might go, okay, we might need to rephrase these questions because they're not extracting as much variance from our students as we want them to. They don't matter as much as we would have liked them to. PowerPoint. Okay, so the first component is kind of question strength. Think of it in that way. The individual question component magnitude is sort of how powerful this question is within your exam set. Think discriminatory power, think you can kind of think difficulty, but that only counts if, okay, we need to consider these ones that were close to 0 or negative, because why were they close to 0 or negative? In this case specifically, it was because these questions were actually just too easy. So the average score on these questions was so close to 1 that we were basically just getting noise for these two questions. So it might be the case that some of the actually very good students thought that, nah, this question is too easy. This has to be a trick question, and they misinterpreted it and so on. That could be the case, but I haven't looked into it much more beyond that. So if you get very close to full score, or very close to 0 score, you get a lot of noise in this data and it's not that useful. If you're kind of in the upper 3/4 and you get this sort of negative variance, then you can be very confident that this was a misunderstood question. And if all of your questions are in this kind of upper half, then you can interpret variance captured as a sort of proxy for difficulty. Kind of, but it's not. Considering difficulty on an exam is kind of, just from the grade set, is very difficult because you as a teacher influence both the teaching and the exam questions. So you're influencing both sides of this thing, so you don't have enough information anyway, so it doesn't really work. But it can be informative in some amount. But these negative or 0 questions, you should consider probably voiding them or rewriting them for next year or something like that, because they weren't useful. So let's look at the second component. So we've extracted the first component, which was how good are you at question A and question B. Most of that information will be you're good overall because you did well on the course, you followed the course material, blah, blah, blah. So what's left now, once we squashed that dimension together, is just either question A or question B. You achieved something on one thing, but not the other thing. So in 2 dimensionals, this makes kind of sense. We're left with that, the opposite dimension from the most capture, but in higher dimensions we get a bit more interesting things, because you get this, in one space you have the set of questions that seem related. You did well on this set of questions, or you did well on that set of questions, and there were some questions in the middle that were unrelated in this specific instance. So what we get are these kind of clusters of questions that seem related in terms of achievement, in terms of specifically student achievement. And labels became quite useful here because you can show up with your own labels, which I used as colors here. So you can put your own labels on it and kind of put your hypothesis to this question. And the principal component analysis will extract specifically just student achievement, like raw scores, for these topic questions, and the clusters that you get out of it are, it just does not care about what labels you put on it. So I consider this kind of an anti-taxonomic approach. The PCA, you bring the labels, and the PCA will just tell you how wrong you are. So let's.
Could you repeat that? I didn't get that point. Sorry.
If you bring the labels and you say, I expect these things to be related in terms of student achievement on my exam, and I expect these things to be related, you can do that. And then if you're right, the colors will match with these nice groups. And if you're wrong, the colors will not match. And you'll be forced to confront the reality of the situation. And you cannot fit the data into your model. The model has to be extracted from the data itself. So this is what I got for this exam set the first time I did it. So I got an expected group here. This is priority ceiling protocols in real-time systems. It makes sense that if you understood one of these, you understand multiple of them, so that's kind of an expected group. And then we got this absolutely weird outlier over on the other end, which means what this indicates is you either understood priority ceiling protocols or you understood cooperative scheduling. This is what it actually means. If there was one of these two things that this was the most important kind of differentiating thing. So there's this very weird outlier over there. Again, I think this might be an artifact of the exam overall might have been too easy, which gives us kind of noisy data. So when we get to later examples, we'll get more useful information out of them. But since this was historically the first achievement on my end, kind of interesting. The 3% captured variance is wrong. That's a bug in my code. That's fixed in later slides. Don't care about it. Then on the third dimension, we get definitions are over here. This is also just a list, a bunch of ways you could do something. So it's kind of book smart. You're able to read what was in the book. You're able to recite that knowledge. And on the other opposite end, if you weren't book smart, then you were probably kind of street smart. So you understood the actual practical applications of why do we use operating systems? Very open-ended question. So why do we not find priority ceiling protocols in operating systems? Again, very open-ended questions. It requires kind of a deep understanding. But even if you have that deep understanding of actually how should things work and how do things work, that doesn't necessarily mean you're able to just recite a list of information.
The percentage of variance that is captured here is going down quite fast.
Yeah, bug in the code, so don't ignore them for these slides that are correct in later examples. I haven't fixed it because these screen caps are from 2018 and I haven't done anything with them. So, but yes.
Because in a certain sense, if it goes very fast, then it means that somehow there's only one.
Exactly. So
way.
We can actually discuss that right now because each of these variance vectors captures the amount of variance. So if you're measuring, you have 24 questions, but they're in pairs of 4, and each of these 4s are actually just the same question repeated over and over. You actually don't have a 24-dimensional space, you have a 6-dimensional space. And you see that you capture 100% of the variance after the first 6 dimensions, and after that you capture nothing. And the same thing here applies here, where if you notice that after a certain amount of questions, you're not actually capturing any more variance, it means that there's some repetition in your question set. Or in the opposite way, if you just have a nice gradient slope, it means that each question is capturing something and it's unique and it's completely disconnected if you have this perfectly straight line in terms of percent captured variance for each question, or cumulative specifically. But that's getting into like the statistical weeds of this. I'm trying to present this first as more of a like kind of an intuitive tool, and we can look at what the numbers mean later. So let's just, for this exam set specifically, let's just look at some observations and opportunities for back in 2018. So it's not going to apply anymore because all of this has been fixed. The softball questions to kind of separate the E grades and the F grades, the failing grades, not worth it because there's not enough information in those anyway. Ask harder questions. Also, they can be misinterpreted as trick questions, which is what I think happened to some extent there. There is that one topic that stands out as a teaching opportunity related to cooperative scheduling because it was just weird outlier. So there's something that some people understood very well there and the rest didn't, which means that something was not communicated properly during the teaching of that course in that aspect specifically. And also an overall thing, we found out that students that are good at analysis are not necessarily good at remembering stuff and definitions. So these are actually might be completely separate skill sets. It's not necessarily the case that you need a bunch of knowledge in order to perform high-level analysis. You might actually be able to do that without the recital part as well. Let's just do another example, number 2 of 3. We do peer reviews of code quality in real-time programming, or at least we did do full peer evaluations. We now just do peer reviews. We can get into the exact story of that as a bonus at the very end, but we're not going to talk about it now. There are 3 generations of that question set from 2018 to 19 to 20. The questions were updated between 18 and 19, and this analysis is kind of after the facts. I just did this intuitively. I looked at the questions and the feedback that came in when they were doing it, and I saw, okay, these things need to be updated. These things are fine. And the after the fact analysis seems to correlate kind of mysteriously well with my intuition at the time. So this is 2018 on the left and 19 on the right. Let's just go through some of, this is the first component, which is just how useful the question is. So it's weak to strong questions, weak on the bottom right or bottom left and strong on the top right. So these questions were rephrased. One of the rephrased questions went from the worst performing, the least useful question to the absolutely the most useful question just by rewriting the question. That's kind of happy. Some of these were rewritten and fell a bit down, but not to the bottom at least. So that's, we take small victories. I replaced one question that turned out to be the second worst performing. Didn't have that analysis at the time, was just intuitively. Turned out to be a pretty good one. That question was removed entirely. Again, intuition at the time, it just felt like it performed poorly, and look, apparently it does. And then added some new questions. Some were pretty poor in terms of performance, and some were surprisingly good in terms of discriminatory power. So the intuitive approach, of course, works, but you could also have used this tool to look like, oh, yeah, these 3 questions need to be done something with. And these ones were strong ones, we need to keep them, or kind of look at the style was used or something like that.
Just a clarifying question. So you kind of talk down these questions to the left,
Mm-hmm.
but in an analysis like this, some questions necessarily have to end up at the bottom.
Yes.
Does that mean that they are bad?
This is an interesting question because, yes, as you say, something has to happen. Something has to end up at the bottom.
Yes.
Right. So what we're not looking for is it bad or good in terms of like the end state of the question. What we're looking for is where should we target our improvement as much as possible. Because we're not trying to make the final version of our courses at any point in time. We're always just trying to make it better. So this is just a way of saying, okay, the things that I need to make better are, am I putting my effort in the right place? Just like a sanity check. It's not, if you feel like, no, it was actually the one that had the most discriminatory power, does need a rewrite because there's something weird with it. This just looks at the data. It doesn't look at, this is not a moral compass, right? And I have put that in the later slide. We'll get there. So this is component 2. So this is kind of topic separation, not question strength. So the topics that we saw here, it's kind of weird ones in 2018. So you either have good comments or you had good usage of kind of variable hiding, private variables and so on. That is kind of does not make a whole lot of sense. The updated question set is much more clear. We have the kind of foundational quality of entry point in your code is, can I look at the top-down view of your code and is like the main structure of your program, does it make sense? And then you have the small picture things like, when I'm looking at a module, does it list up the right things in terms of the naming of it? Are the variables and functions named properly? These are not structural things to the code, it's just a navigational text parts of the code. So you can either make it look like it's doing the right thing, or you can actually make it do the right thing. And those are kind of the main separations there. Because there's two quick fixes. There's the quick fix, which is kind of up here, and then there's the long-term fix, which is down there. And then this is component 3. I have absolutely no idea what's going on over there in 2018. I was not able to extract anything useful, and that happens sometimes. Sometimes your ability to pattern recognize what is going on there, it just does not make any sense, and I'm not able to extract anything useful from it. And in 2019, the updated set makes a lot more sense. So after the question updates, the structure is starting to fall more into place. So that is also a way you can evaluate, is this question set, does it make sense or not? Not just looking at the first component, but looking at 2 and 3 and maybe also 4 if you're lucky. Do the groupings make some amount of sense? And if they do, then you can go, okay, I like this. And if the groupings are something that you don't want, you can go, okay, I don't like this. But it doesn't tell you what you should be liking, right? So for 2020, let's just quickly go over that. These are the same ones as 2019, but now principal component 2 and 3 have swapped orders. So now the declarative imperative dimension is more important, and then some of these yellow ones swapped sides. I don't know why, but they just did. So maybe they're not that important anyway. And principal component 3, we got the same as 29, or yeah, let's go back. So these ones are actually new ones, and kind of new ones. There's still this kind of non-code text thing, like variable naming and so on. It's not a structural thing. And then you have the module and variable dependencies, which is the structural thing in the code. And then again, we have more or less the same thing again. It seems like this structural and non-structural thing is a very important aspect of kind of two-dimensional aspect of code quality. It seems like a recurring theme. But yes, it's not a perfect system, of course. The numbers, as we've briefly touched upon in several aspects, are not really meaningful until they are interpreted by a human, preferably. These numbers doubly so because the x-axis here is unlabeled, because putting a label on it it's kind of a weird label to think of it in terms of distance in a vector space of question variance captured. It's not an intuitive number. And then percent captured variance, again, you don't want it to be 100% because that means you just ask one question 24 times. And you don't want it to be 1/24 because that means that everything is completely uncorrelated and you're not actually, none of your questions interact with each other at all. So it's completely qualitative, and you do need some amount of interpretation. And of course, there is no algorithm for truth. There is no algorithm for creating the best course in the world. You just need to trust yourself in some aspect as well. It is like the averages that you pull out for each question at the end of an exam session. You can't say that, oh, the average was 0.73. That's perfect. Like, it doesn't. It is not something like that. You can't use it like that. There is also the possibility that your pattern recognition part of your brain goes too deep and finds patterns where there aren't any. That also happens. Sometimes we get these hard to reproduce the same components year on year because the student population changes, your teaching changes. You're not going to get exactly the same thing. But I contend that there is much more information here than just these per question averages and the final histogram, which is what everybody does. So it is just a useful tool. So you can say that the question set is good when there are no of these very outlier, very low or very negative ones on the first component. And the groupings that you see on PC2 and PC3, and if you're very lucky, PC4 as well. If these groupings are things that you want to be grouped, because you do need to propose as a sort of, what do I want these things to be grouped? Do I like this kind of book smart, street smart separation in my exam questions? Is this a desirable outcome, or do I want more of a topic separation? You do need to choose. This doesn't tell you what to do, it just tells you what reality is. If these clusters are so strong that you're measuring the same thing over, then maybe eliminate some questions, replace them with something else, and so on. So you can rewrite questions, make the weakest one the strongest. You can add things that find new dimensions into your problem space, and For example, in code quality, the following information flow one performs surprisingly well as a way of determining code quality. And if you have these weak and duplicate overgroup questions, you can just remove them. If you're measuring the same thing twice, don't. Here it is. I use this also on the factory acceptance test. We run their elevator programs. This is a distributed systems system. And this is kind of my dashboard when I get all the results in, and I go, does this make sense? Are there some questions that need to be voided because the results don't make any sense? There were 2 questions here in 2022, I believe this was. These were just annulled because there was a bug in the specification where if I tested this, it was actually not the correct thing to test because it was illegal in terms of the specification. That was my bad. It turns out some of these test this cluster over here, testing the very basics of like, does the elevator not move from a floor when the door is being held open? Like very basic stuff. Turns out that it's not a very strong performer. So we kind of cut back on that for a later year because it's not that useful. But we still need to test it because it is so basic that if you fail this very basic thing, then you do deserve not getting credit for failing the basic one. PC2, we got some interesting things. You'll just have to trust my interpretation here, but if you don't trust me, come and talk to me. We have the normal operation, like do the lights for the buttons on the distributed button panels, do they turn on and off in the correct sequence when we are in a normal operation? You push the button here, the light turns on everyone, and so on. Kind of normal operation on the bottom left, and then we have the exceptional cases where when we have the DC, the disconnects, we plug out the network cable, does the system still operate as it should when they are no longer able to communicate? Is it partition tolerant? So normal operation on one end and exceptional operation on the other. And then PC3, it's not so clear in 2022, but later year. We get this very even ramp on PC1, which is, might be good, might be bad. Part of this is also weighting, because these numbers are actually post-weighting. And you can think of this as kind of a difficulty ramp, where it's the easy questions are out here. They don't have a lot of discriminatory power. And the reason why I can say that is because I know these results are from 0.7 to 1 and upwards. They're not from 0 to 0.3. If that was the case, it would have been the opposite. That would have been kind of anti-difficulty instead of difficulty, if anti-difficulty makes any sense. But because I know this all lives in the upper third of the space, I can kind of interpret this as a difficulty ramp. And I know that this DC light sync is by far the hardest question for most people to actually get right, in terms of the average score for it is only about 50% usually. Functionality, I get this one. If you've programmed your system, sometimes in the events of disconnects or failures, the others take over as one dimension, or the rest of them keep working. So that's the most common kind of missing feature. And then we recreate this normal operation in exceptional cases thing. This one showed up in PC3 this year instead of PC2. So which ones show up where, in the ordering of them kind of changes a bit here and there. And these are the 7 lines of code. It's just you normalize, you pull out the components, and then we sort them and normalize them so they're tending positive, and then we just plot them in a scatter plot and we call it a day, and that's it. It's that easy. So I'm confident that you'll be able to pick up this kind of tool and use it in your daily life and be like, yeah, these results seem useful, or these results do not seem useful, and you can kind of interpret it from there. And that is the end of the scheduled talk, but there are. But there are 2 bonus slides which are available on request if you ask the right questions.
Tons of questions, but
yes. Yes. Good.
The first one is that I got the feeling that for interpreting correctly the results, you need also to see somehow the actual grades. So, because we are being centered, but if it is like between 0.03 or between 0.7 and 1, the kind of the interpretations are...
Let me just repeat for the microphone, which I am wearing, that in order to interpret the results correctly, you do also need the average scores available somewhere else. You cannot just use this. I completely agree. You do. Yes.
And the second one is about the Gaussianity of the distribution, in the sense that they both... ideally they are on some hypercube.
Mm-hmm.
But are they, probably depends also the shape. I'm kind of curious to see the scores plot associated to those, to see,
Yep.
there might be some kind of non-Gaussianity that kind of hinders.
So the question is not just looking at the loading spots, but also the score spots and see if you get some kind of interesting shapes out of it. I haven't actually done that. Or maybe I have and I just realized that it doesn't make any whole lot of sense, because a lot of these things are just binary. So it's just you got a point here or you did not get a point there.
Okay.
And so you're not going to get any interesting shapes out of it really, other than just a triangle and 90-degree corners and so on. So it's not going to be 90 degrees because your space is skewed, but if you unskew the space, it's going to be 90-degree corners. So it's not that informative until you get these floating points, proper gradients into it. But if you group the scores first and then do that again and then kind of reinterpret it, then you can get something useful probably. But I haven't done that, so exercise for the reader, I suppose. Yeah?
So I guess two questions kind of related.
Mm-hmm.
It's very interesting, but isn't there really sort of two effects which are sort of linked, because you have the questions in themselves, and maybe you could argue that in order to cover the most ground with the least amounts of questions, then in a sense the question set in itself, if you can even talk about that, should be orthonormal or orthogonal.
Yes.
You should
Yep.
sort of, every
Yep.
time you add a new question, you should sort of cover as much as
Yep.
of the remaining curriculum as possible. But then you have the student mass, and in the student mass, of course, it's very likely that a person who's going to score well at question A is also going to score well at all the others. So there's a correlation there, and then it's difficult to sort of untangle where the sort of covariance between the questions really sort of occur.
I'm not going to accuse you of your question not really being a question, more just an observation. But
Yeah.
I am going to accuse you of that. And the observation is correct. That if you do formulate a perfectly orthogonal question set, and then you filter it through the students who are not orthogonal and don't operate by the rules
Right,
of
yeah.
math or other satanic rituals, they will turn your orthogonal question set into something that is correlated, and you will be able to extract something out of it.
Yeah.
And yes, being able to differentiate between what is the function of student achievement and what is the function of my exercises is something that is basically impossible to do. I think you may have unlocked the first bonus slide. But it depends on your second part of your question.
Yeah, I think it's very sort of correlated. It's essentially you talked about you can sort of look at the questions and see if you want to have a correlation, for instance, or this either or with, for instance, theoretical knowledge and practical knowledge.
Yes.
Isn't that really more a function of that typically in the student you have sort of often at least an affinity for either the sort of theoretical realm or the practical realm. Often at least you're sort of either very into the sort of nitty-gritty or you're good with your hands, so to speak.
Yep.
That's not necessarily something you can just tune by changing the question set because it's a property of the students.
Yeah, that's correct. You can't tune what clusters you want to show up on components 2 and upwards. You cannot target something and actually achieve it. But what you can do is post hoc say, I targeted something and either did or did not achieve it, and from that, use that as an instructive lesson on what you should try to work on in the future. That's all you can try to do to it. But I think you may actually have unlocked the first bonus slide. So let's go to the first. No, this is actually the second bonus slide. Don't read this one. This is the first bonus slide. It's the bonus slide ordering was spoilers. Okay. Now, first one is that the grades are fundamentally kind of a scam because you influence the teaching, which influences the student achievement, which influences the grades. And you also influence the exam questions on the exam, I would presume, unless you outsource this to somebody in Taiwan. So really, the only thing that actually influences the grade distribution in the end is actually a bureaucracy that requires you to not give an A to everyone or not give an F to everyone. So the ability to differentiate what is a difficult question and what is an easy question based on the grade outcomes is basically impossible, because the better you are at teaching, the harder you need to make the exam in order to satisfy bureaucratic requirements. Other part of this is actually not just an influence on you, but the influence on the student. So if you ever have somebody in your class asking, will this be on the exam, this is a function of the bureaucracy demanding there be grades on the exam, and which kind of influences student behavior. Which is kind of related to the thing you're looking at. Everything will be filtered through the student's activity, and they will optimize for. There is a contingent of students that will optimize for grades, and there is this contingent that will optimize for actual learning. And unfortunately, we cannot fire the ones who are just looking for grades. So you cannot really use the raw histogram grade outcomes as really useful feedback metrics. The only one who can use that as a feedback metric is some administrator who says that you're giving out too easy grades. So this is the first bonus slide. Congratulations, by the way. Yeah.
There's also the other one. Now you've got to show the other
Yeah.
one.
Okay. So let's look at the second bonus slide, because apparently I unlocked it. So we did peer evaluations, like actual peer evaluations, where they gave each other points, and we used those points for code evaluations, and it turns out this is a bad idea. Of course, you get this blind leading the blind effect. And I tried to identify non-blind participants by looking at, okay, so this review got a lot of really high variance in. When others reviewed them, the results that came in for that group had a lot of variance, like a suspiciously high amount of variance. So I looked at it, okay, there's a large amount of disagreement in the student body about this group in particular. I need to put my own expertise insight into that and identify which one of these evaluators was most correct, give them higher weights, and those who were just wrong, give them lower weights. And the result of this is that my intention was that, okay, I can identify the non-blind participants so that they can lead the kind of the rest of the pack. It turns out this is very hard. The ones who are able to teach themselves to perform this task tend to be very Pareto distributed. It's a very skewed distribution. There's like 5 groups that are able to actually teach themselves to the competence level required without mentorship out of like 80 groups. So that is just not enough people to do this. You cannot rely on the autodidacts in this scenario. And it's just a function of that high quality learning actually does require these kinds of 3D lessons where you have an active mentor talking to them. So you need to show up in front of your students and actually teach them. You cannot just give them a book. Because what happens if you just give them the book, and the book in this case is this is the list of criteria and this is how you should interpret them. Where did the text go? Oh yeah, it goes here. If the student reads the book and then evaluates somebody else, okay, yeah, they read the book, they understood the book, and they evaluated somebody else. Then the teacher reads the book, and they evaluate themselves, okay. Why couldn't the first group just evaluate themselves in that case? Right? They both read the same book, and they both had the exact same experience, they both learned exactly the same thing. You just did the same thing, but with more work. So you just had 7 groups evaluate one group when they could have just evaluated themselves and you would have gotten exactly the same results. It doesn't really matter. So you need that 3D mentorship involved anyway. So if you're going to have that in-person mentorship anyway, just show up and evaluate everybody in front of them, which is what we ended up doing. So we called in every single group to a 20-minute meeting. They still look at each other's code. They still give feedback to each other. But at the end of that process, we don't use the points that come out of that. We take them in for a meeting. And we look at the feedback that they received from others. We look at the final gut feeling score that they gave to each other, and then we look at their code, and then we go through all of that in 20 minutes. It's a ton of work. It's mentally absolutely exhausting. But a lot of students have said those are the most important 20 minutes of that course. So that works. Just showing up in front of your students is absolutely the only way to do it. So if you need mentorship to achieve proper learning, why not just do it for the entire evaluation process? Just take them in. Just be in front of them. It's the only way to do it. Yeah. If there are no further questions.
You should probably write a paper on this last thing, because peer evaluation is a big thing.
Yes, but the paper is basically just, what are these? 5 words. So it's just, So there's.
You should do a paper and then put like the armor of the ancient knights and go to Dracula and start.
How about we just skip the paper part? Yeah. Now, but if somebody wants to take these ideas and run with them, I'll show up and help you run, but I will not actually be doing this as a paper myself because, frankly, I cannot be bothered. So, and with that.
Should make it a paper with him as
No,
a-
this is actually very interesting. The analysis.
Oh, yeah, here's something interesting you can put in the paper. So my idea was, okay, I'm going to try to decrease the overall variance in all of the evaluations by adding my expert score and then finding the non-blind participants and giving them higher weights. So the question is, does the overall variance increase or decrease when I add my own kind of expert evaluations into the system? What do you think?
Decrease. I would say it should decrease.
Yeah, but you'd be wrong. It actually increases. Why? Because I am disagreeing with some students. And my disagreement with somebody else, that is variance. So I'm adding variance into the system. So the only way to actually decrease the variance is to change the weights so dramatically that you end up with one evaluator, and that's just me.
And at this point, there's no sense to do field evaluation.
Yeah, exactly. So statistics,
Share
fun.
the 7 lines of code with us.
Yeah, okay, fine.
I've got another
Yeah.
meeting. I remember.
Yes.
Very interesting.
Yep. 15 minutes, by the way. Yeah. Okay. Well, thank you for your time, everyone. Yes.